Hello, this is P5 2023 iTong School Term 2 Review Paper. So you are allowed to use a calculator as stated in the instructions here. So let's begin. So 9 to 5 ratio is equivalent to something to 40. Okay, so I'm just going to start off by writing 9 to 5 and something to 40. I'll present it in this manner. So looking at the changes on the right hand side, you notice that 5 times 8 actually gives us that 40. Hence, you apply the same thing to the left-hand side. Also times 8 suddenly. Okay, and that gives us 9 times 8, which is 72. So that's the missing number. Question 2. The cubicle container shown has a height of 12 cm. What is its volume? So cubicle comes from the word cube, in case you're not aware. Okay, so cube, what's so special about cube? A cube, the length, breadth, and height are all the same. Okay, so since the question has already given us that the height is 12 cm, I can safely say that the length here is also 12 cm, and hence the breadth is also 12 cm. Alright, so to find the volume, we go by the formula that we have learned, length times breadth times the height. So simply 12 times 12 times 12. So if you key this into your calculator, you will realize you have 1,728 cubic centimeter. Okay, so units are stated there for you already. Now, question 3. So two identical squares are joined together to form figure ABCD. Find the area of the shaded part. So we look at this shaded part, it's a triangle that's within one square, but there are two squares here, and we see that the two squares together DC, the length is 16 cm. So we should find the length of one side of the square first. So simply we 16 divided by 2 to find one side of the square. So that means I can say this will be 8 cm, and the height here is also 8 cm. Okay, and you notice then to find the shaded triangle is actually pretty straightforward already, because this shaded triangle, I noticed that the base is 8. This perpendicular height that I will drop down here is also 8 cm. So where is the perpendicular height that I'm talking about? Over here. All right. Some of you, without dropping this height down, you may be even, you can even probably straight away tell that the triangle is half of that square itself. Yeah, we draw properly. All right. So some of you, you are probably faster at observing this. You probably can tell that the shaded triangle is in fact half of this one square, because the base of the triangle is essentially one side of the square. The height of the triangle essentially is also the same one side of the square. So half times base times height means half times the area of the square to get the shaded triangle. Okay, so we just apply that half times 8 times 8. Okay, so this works out to be 32 square centimeter. Question 4. So the figure shows triangle EFG. EG, so EG is here. So they say EG is the base of the triangle. Okay, so I'm just going to highlight the base first, since the question already defined the base for me. So this is my base. Now the fact that they have already defined this base for me means that I need to figure out where is the appropriate perpendicular height that's perpendicular to that highlighted base. Okay, so what I strongly suggest you all to do is you can rotate your paper around such that the base lies at the bottom of the triangle. Otherwise, by looking at this like that, some of you may not be able to tell. Okay, because there are so many lines here, I understand it's confusing. there are in fact 3 sets of right angles shown here. So like I said, okay, if you want to lessen the confusion, rotate your paper around such that the base is at the bottom of the triangle. Okay, I can't really rotate my page now, but I hope you get what I mean. So once you have rotated your paper, I hope you are able to tell that the perpendicular height is in fact this line. Because that line is the one that is touching the corner opposite the base. You see the base is EG, the corner opposite EG is F, corner F. So this yellow line is dropping down from F, and this yellow line is also a perpendicular line to the blue line. Although they are not directly touching each other, but that is okay. You don't have to worry about them touching or not. You just need to fulfill 2 conditions. Perpendicular to base. Second one is dropping down from the corner that's opposite the base. Okay, so the answer simply will be which one is the corresponding height? Answer is just XF or FX also can. Question 5. The figure shows some 1 cm cubes glued together at the corner of a room. How many 1 cm cubes are there in the figure? Okay, so we need to count how many cubes are there. So when you count, there should be some structure to counting. Normally, I count the bottom layer first, then the top layer. Okay, so bottom layer means those that are touching the ground. So if you count those that are touching the ground, you can start from this 1, then the corner is 2. So 2 here already. Middle is 3, 4, and 5. Okay, so there's 5 at the bottom layer. And of course, second layer, we can see is just obviously 1 cube. So together it's just 6 cubes, 5 plus 1. Part B, we ask us to draw the side view. Okay, so side view is indicated here. Follow this one here. So side view, if we look at the bottom layer first, bottom layer, you'll notice there should be 1 square and 2 squares, these 2 squares. The back squares should be hidden by these 2 squares here. If you look at it from a side view, because anyway it's 2 and 2, so the maximum is 2 squares at the bottom layer. I'm just going to shade it so that we can tell where the 2 squares. All right, and at the top layer, we should see only 1 square. And this 1 square, it should be lying on top of this square. So that means on top of the one here, on top of this square. So we need to shade this one. Okay, so that's it. This is the side view. Okay, so we are moving on to section B, question 6. So this section onwards deals more with the word problems. Okay, so square ABCD is made up of 4 identical small squares, the below ones, 1 rectangle, which I believe is this, and 1 large square, which will be this one, the large square. Okay, express the ratio of the area of 1 small square to the total area of the figure. So notice that this question, they didn't really provide us with any measurement. They never provide us with like sides of squares, the area, the perimeter, and things like that. No values at all. They simply just ask, they want a ratio of the areas. Okay, so how do we do this? So if you are lacking information, the question didn't provide you with values, what you should do next is to analyze how the diagram is arranged, how the shapes are arranged. So if I focus on this side first, when you deal with squares, it's easier. Don't care about the rectangle first. So looking at this part, you notice that 3 small squares are lined up against these large squares, right? So that means you can actually proceed to try to cut the figure. So what do I mean by that? I can cut it into 3 columns. In a way, what I try to understand is also that the length of this big square, this one, the length of the larger square is 3 times the length of the small square. Okay, so I hope you all can agree with me on this. I'm just going to cut this way. Please use a ruler if you're cutting. All right. Now, the fact that I cut it like that, such that one side of the big square is 3 small square sides. means that I should do the same for the vertical side here, this one. All right, which also means this side, I should cut it into 3 small square side also, like this. Okay, in this way. Okay, so now that I've cut, of course, this diagram is not drawn to scale, but just nice when I cut, I realized, okay, it's very, it fits perfectly well. Okay, which means that y'all can do for the rectangle also. So we're going to cut it across in this way, just extend the dotted line in this way also. Okay, so I think it's pretty straightforward from here already. So now looking at the area of 1 small square to the total area, for 1 small square, we will treat this as 1 unit. Total area, you just count how many small squares are there. So 4 rows of 4 squares, right? So that will be 16. Okay, so it's actually a 1 to 16 ratio. Okay, so now we go on to part B. The area of the large square is 144. What is the area of the shaded part? Okay, so large square, they are talking about these large square. All right, not the whole thing, because the large square is stated in the first instruction being this one. Okay, so if you look at a large square, it is now made up of 9 small squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the 9 small squares. Okay, so now I can write this down. This will be the same as the 9 small squares. Let me draw the square properly. Okay, in other words, if I want to find area of 1 small square, I simply just take my 144 divided by 9 to find area of 1 small square. You do not need to go and square root the 144 to find one side of the large square. You don't have to do that. Okay, because if you do that, that means you're finding one side. Actually, finding one side also can, but it will be a longer way towards getting your final area of the shaded part. Since I already have area ratio here, I also got area given here, and I also need area of shaded part. Just do everything in terms of area. It will be so much easier also. Lesser step to work with. Okay. Okay, so now let's look at the shaded part. As we can see, shaded part is made up of 4. 4 small squares. 1, 2, 3, 4. So simply find area of 4 small squares. Okay, we can just take 16 times 4, which will be 64 square centimeter. So that is our answer here. Okay. Question 7. The box shown below is 18 cm long, 10.5 cm wide, and 20 cm tall. So long means the length, wide means the breadth, tall means the height. Okay, sometimes the question will not give you the diagram here, so you must understand long, wide, and tall means with respect to the length, breadth, or height. Okay, so normally the last one will always be the height. So John fills the box with as many 1 cm cubes as possible. How many such cubes does he fit into the box? Now, for this question, a lot of students have this mistake. Yeah, I'll show you what is wrong. Do not copy this down. Okay, so the wrong method is you always like to do 18 times 10.5 times 20. Okay, and then you tell me the answer. Let me just calculate this quickly. Okay, 3780. Then after that, you all take 3780. You divide it by 1 because they take 1 cm cubes, right? All right, 1 cm 3 lah. Actually, 1 times 1 times 1 is also 1 cm 3. All right, and you tell me the answer is 3780. Okay, so you cannot do it this way. If you do it this way, what you're trying to visualize or what you're trying to repeat is that you are saying that if there are gaps in the container after you fill up with small cube, those little gaps and little spaces in the container will be also additionally filled by part of a small cube. You should expect a remainder somehow. Okay, why do I say that? Because of the 0.5 gap. Even if you don't expect a remainder, you can't do it this way. You cannot take area of the whole thing divided by the area of one small cube. Because, oh, whenever you do it that way, you're actually saying that, oh, I'm cutting up a small cube and then I'm squeezing those cut up pieces into the gaps into the big. So that's the idea that, these two steps are illustrating. And we don't want that, because what we want is we want to fit 9 whole small cubes nicely arranged. And if there's a gap in the big cube, after you fill, then you realize that, oh, there are spaces in the big cube. Then it's okay, just leave them alone. Those spaces you can't squeeze in another small cube, then that's fine. All right, so what we want is that idea. I'm going to erase this. Okay, so how to work along that idea that I mentioned? So in this case, we do this grouping concept. Okay, so when I say grouping concept means what I'm trying to do is along the length, I want to try to fit many of these small cubes. So you see what I'm drawing here. Okay, my drawing is not perfect, but I hope you get my point here. I'm trying to find out how many cubes I can fit along the 18 cm. So this is where you realize that, okay, every small cube is 1 cm, 1 cm, 1 cm, right? To find out how many 1 cm along the length, you will have to do 18 cm divided by 1 cm. Okay, so luckily this one no remainder, 18 cubes along the length. This is what it means, okay, when you do the division. So you should be starting off with a division step. Now, seeing along the breadth, okay, I don't know how to draw breadth out loud, okay, but I hope you get the gist when I explained earlier. You're fitting a lot of small cubes along the 10.5 cm. That means you're fitting along a lot of 1 cm along the 10.5. So again, same thing, we're doing a division step, 10.5 cm divided by 1 cm. Now, of course, when you key in this in your calculator, or actually just mental calculate, you know that the answer is 10.5. The problem is I cannot put 10.5 cubes, because this answer is for cubes. I cannot have 10.5 cubes. I'm not going to cut a cube up into half. See, that's what I'm trying to say. We're not cutting a cube up. Okay, so the way to do this is you should only write 10 before the dot, before the decimal point, you write 10. So that means 10 cubes along the breadth. But you should also go on to create the remainder. Okay, so we're going to create the remainder. Now, how to create remainder? What you do is you take 10 multiplied by 1 first, because 10 cubes of 1 cm means 10 times 1. 10 times 1 is 10 cm. Then to find the remainder, you take 10.5 minus off that 10 cm from this product, which will leave us with a remainder of 0.5 cm. Remainder will be cm, yeah, because the whole thing is cm, means the beginning number is cm, means the last remainder is also centimeter. Okay, so that means I place 10 cubes along the breadth with a gap of 0.5 cm. And that 0.5 cm, can I squeeze in more cubes? You cannot. Okay, you cannot squeeze in more cubes. So no choice that the 0.5 cm is just a gap there, leave it alone. We're going to do the thing along the height now. Okay, so 20 cm height, I want to fit many 1 cm cubes. So same thing, 20 cm divided by 1 cm. So 20 cubes along the height. Right. Now, finally, we can find out how many cubes to fit into the box, which means we need to do something with order, along the length, along the breadth, along the height. Okay, so we should multiply, because length times the breadth times the height to give you the total number of cubes. 18 times 10 times 20. Okay, and that will be 3,600 cubes at most. So you see, it's different from my wrong answer previously that I illustrated just now. Just now I demoed using red pen. If you do 18 times 10.5 divide, this times this times this divide by 1, your answer will be 3780. Okay, no, because like I said, like that one is the wrong logic. The right logic is to find out how many cubes to 90 feet along the length, breadth, and height, then multiply them together. Okay. Question 8. So Jenny had a bottle of juice. She drank 525 ml on Monday and 1/5 of the remaining juice on Tuesday. So we see the word of the remaining here with a fraction. Most likely we can use a model, drop-down model to be specific to illustrate this whole thing. Okay, so I'm just going to draw out the total juice first. This is what she has at the beginning. So she drank 525 on Monday. Okay, so I am going to park aside 525. This is for Monday. So these are the labelings to write down. Okay, and 1/5 of the remaining juice on Tuesday. So that means identify your remainder next. So this is our remainder. And what we're going to do is we're going to redraw this remainder down into a new layer. By habit, we always do that. I know some of you, you don't want to draw it down. You rather just cut 5 units in this top layer. Now that is all right. Okay, just that I'm trying to stick with what we consistently deliver during lesson. When we have a remainder concept for fractions, typically we always redraw the remainder layer down. Okay, we try to be consistent with how we approach such questions. So now that I've dropped down the remainder, I can cut it into 5 equal parts. Now, and I'm going to label 1 out of 5 on Tuesday. They say 1/5 of the remainder on Tuesday. After that, there was half a bottle of juice left. Okay, so of course, whatever is left is this part. So you see, I don't care about the half first. I focus on Monday, Tuesday, then whatever is in the end is the leftover. Label that down first. Okay. Now, so this left and this left. They say half bottle left. There are 2 information for left. 2 information you'll notice. Okay. So the first information is the half. Second information is your model units. As we can see, model is 4 units. Okay. So first, I need you all to understand. The left here, when I say half left, be clear what the 1 and the 2 mean in the numerator and denominator first. So I hope everyone agrees the 1 here represents the left. The 2, if you don't know what it refers to, read this part. Half a bottle of juice. Half a bottle of juice means 2 is the whole bottle of juice. So you can call this the total. Now, the thing is this. Based on my 2 information for left, I notice that fraction-wise, it shows 1 unit. Okay, I highlight in green. However, on my model, it shows 4 units, right? So the information is like not consistent. You know, here shows left numerator is 1 unit, but yet my model, when I count, it shows 4 units. So what you have to do is to make the 2 information match each other. Either you adjust the model, or you adjust the fraction, or sometimes, in worst cases, you have to adjust both things to make the number of units look the same. Luckily for this, we just need to adjust the fraction because on my model, since it shows 4 units left, and this 1 unit left, I can just easily change it to a 4. Just need to times a 4, which means 4 over 8. I hope you all see what I'm saying now. See, now finally 4 tallies with my model 4 units here. Okay? Now that also means my new total is now 8. So this one is now my new total. The new one. This is the left. New one. So do not care about the 1 and 2 here anymore. Focus on working with the 4 and 8 now because these are your most updated, reliable units that you have ensured the information, model information and fractional information now matches each other for the leftover part. All right. So in other words, now I can simply say total, this whole stretch is now 8U. 4U is the left, hence this will be 1U each. Right? It has to be 1U each in order to be 4U for the left. And then, of course, it's 1U for Tuesday, which means if you look at the remainder, 1, 2, 3, 4, 5U, right? Remainder is 5U. So I hope everyone can tell for the Monday, can you see it will be 8U minus 5U. So hence this will be 3 units. So there you go. You can begin solving using that 3 units for Monday. 3 units is 525. Cross work out 1 unit. This works out to be 175 ml for 1 unit. So reading back the question, we want how much juice in the bottle at first. So at first is a whole stretch of 8 units. So just find 8 units. Okay, and that leaves us with 1,400 milliliters. You must write down your unit of measurement. Okay, question 9. ABC is a piece of paper in the shape of a triangle. AB is perpendicular to BC, and AB is of the same length as BC. Okay, so AB, BC, they are the same length. Now, it is then folded as shown below. So if you notice the way that they are folding, okay, the way the paper is folded is that it's folded along this dotted line. I hope you all can see that, okay, because end up your corner D is here at the most corner after folding. It's folded along this dotted line, basically. Part A asks us to find the length of BC of the triangular paper. So you want to find BC over here. Okay, so in this case, we are given this 9 cm, we are given this 6 cm. So what I can suggest us to do is that we are going to redraw back the original diagram on the folded piece of paper. I use dotted lines to do the extension. I can't draw very nicely, but I hope you all roughly understand what it looks like. Okay, so I'm unfolding it back as if it's going back to the original piece of paper. So that it's easier for me to tell. Now, if you notice, right, when I fold it to here, okay, or when you say unfold it back, you should observe that this base here will also be 6 cm. Okay, because when I unfold, anyway, this base here will be the same as the 6 cm base that I have unfolded back. Right? So this will be 6 cm. So with this, I can actually work out what is AB already. Okay, let me write down what means AB. So you notice that to find AB is basically adding these 3 numbers up. Right? Now, if AB is 21, BC no issues because remember BC is the same length as AB. So BC equals to AB, which is equals to 21 cm. Okay, now B, find the area of the piece of paper when it is not folded. Okay, so when it is not folded means if you look at this one, okay, when it's not folded, you notice that the height of the triangle is 21, base is also 21, which is AB. Okay, so you just need to apply the triangle formula. Times your base times your height, which will give us to be 220.5. So area can have decimal, not to worry. Square centimeter, and for that. Okay, question 10. So triangle ABC and triangle DEF are identical right-angled triangles that overlap. So ABC is here, DEF, they're overlapping. Okay, ratio of BC to FC is 5 to 2. FC is 7 cm. Okay, so I'll write down the ratio first. BC to SC, 5 to 2. Okay, so very nice. They already give us FC is 7 cm, right? So I think we can straight away say 2 units is 7 cm. Quite obvious. So 2 units is 7 cm. So we can work out 1 U. So BC, as we can see from the ratio, is 5 U. So just work that out. This works out to be 17.5. Okay, so I think we should annotate on the diagram also. So this is 17.5 cm. As you can see, 17.5 also serves as the base of triangle ABC. Okay, so that may be helpful later on. All right. Okay, the next one, find the area of the shaded parts. Okay, so there are two shaded parts here. Now, these two shaded parts, I can confidently say they are the same area. Okay, these two shaded parts have the same area. Why do I say that? The reason is because the question already said these two triangles that overlap are identical triangles. If those two triangles are identical, and also they share the same overlapping part, which is this small little white one, I can then simply say their remaining shaded areas must be having the same areas as well. Okay, so very nice. These two shaded areas definitely will be the same. So now what I'm going to do is I'm going to work out area of one triangle and then area of the overlap triangle, and then I minus off. When I minus off, I'm getting one shaded part. Then later, subsequently, I can find both shaded parts because both shaded parts, like I said, share the same area. So that is my approach from now on. All right. I'm going to find out area of one triangle first. Maybe let's call it triangle ABC. I use ABC as a guide. So half times the base is 17.5. And the height is 10 cm. So notice they stretch out this whole arrow and they wrote 10. So this is 87.5. Okay. And for the overlapping white triangle, base is 7, height, the small dotted line here is a 2. So easy. Okay, so we can call that overlap triangle. So half times 7 times 2, which is 7. So now I work out one shaded area. I take one triangle minus all the overlap part, which is 80.5. Okay, so now if I know this shaded area is 80.5, the other shaded part is also 80.5 because like I said just now, the two triangles have the same area since they're identical, and since they share the same overlapping part means their remaining shaded parts must be equivalent to each other also. Okay, so we can just do 8.5 times 2, which will give us 161 square centimeters. Question 11. Joseph and Daniel shared $884 in a ratio of 6 to 11. So right now the ratio first, J to D, 6 to 11. How much does Daniel have? Okay, so 884 is what you're sharing. And that means 884 is the total. If that is the total, means I add up the total units. And I can say this 17 units will be the $884. So of course, find one unit. Which will be 52. How much does Daniel have? The question wants Daniel, so Daniel has 11 units. So that's it. This is pretty straightforward. Okay, next one. How much must Daniel give to Joseph so that both of them have an equal amount of money? Okay, so what I'm going to do here is I will go on to create like a before change after using the ratios that's stated there. Okay, no, sorry, actually I won't use the ratio lah. Since we've already found out how much Daniel has, we can just use Daniel's actual value 572. All right, so I'm going to work out I'm going to work out Joseph also. So Joseph at first will be simply by taking 884 minus what Daniel has. 884 minus the 570. Will be $312. So using this 312 and the 572, which is Daniel at first, I'm going to create the before information first. So J is $312. Daniel is $572. I'm going to show the change. So the change is that Daniel is giving to Joseph, but we don't know how much he paid, so I put minus question mark. Whereas Joseph is receiving, so Joseph plus question mark with money increasing. Okay, and they say so that both of them equal. Equal, you can use a ratio to illustrate J to B. Equal means 1-to-1 ratio. Okay, that's the simplest ratio. So during this transfer, we should observe that the total did not change because the internal transfer B gives to J. It's just internally within both of them. So the total stays the same throughout. So I'm going to work out the total that both boys have. Actually, total we already have it, which is the $884. So we can just use that. Okay, and in other words, that means these two units is the same as this 884. Now, those two, I'll call it two parts because previously we already used the word units now. Okay, so let's call it part here. Two part is 884. So you can work out one part. So once this is done, if you read on how much must Daniel give to Joseph, that means the question mark. We're interested in the question mark. So you can pick any guy. You want to pick Joseph, you want to pick Daniel, up to you. Both question marks should be the same answer anyway. Okay, so let's say I pick Daniel. That means 442 is what Daniel has in the end. Okay, so I'll put D in the end. So that means now I can find out how much Daniel received. How much Daniel give away by focusing on Daniel at first, Daniel's change, and Daniel in the end. So simply 572 minus 442. So $130. If you use Joseph to solve for the last step, also can. It will give you the same answer. Okay, a tank measuring 40 cm by 12 cm by 32 was 5/8 filled with water. The water in the tank was then poured into as many pails as possible. Each pail can hold 1.5 liters. What was the volume in the tank at first? Okay, so when you do volume questions, especially involving water, your priority is to focus on the water volume. Do not focus on capacity of tank. Capacity of tank is the last thing you should worry about. Okay, so focus on the volume of the content, the volume of the water, or it could be the volume of the solid that was dropped in, things like that. Okay, so if I find the water at first, simply length times breadth times the whole height. But since it's only 5/8 filled, you can straight away times 5/8 in the same step. So 40 times 12 times 32 times 5/8. So some of you, you go and what? You take 40 times 12 times 32, then the answer divide by 8 times 5. No need to do that. Times 5/8 is the same thing as those. All right, so you're just shortening it a lot also. So this will be 9,600. All right, that's it. That's the water effort. 9,600, either you choose ml or cubic centimeter. Both are fine. Now, B, what was the volume of water left in the tank after filling the pails with water? So we are expecting a remainder in the tank. Okay, so notice that each pail, it says it can hold 1.5 liters. Now take note, liters and cm3, the unit of measurements are very different. So do your conversion first. Always convert all to cm3 first. Then you can proceed to do whatever you need to do later on. Okay, so 1.5 liters, let's convert to cm3. So 1 liter is 1,000 cubic centimeter. So that means times 1,000. So we times 1,000, this should give us 1,500 cubic centimeter. Okay, so every pail can hold this much water lah. So now we want to find out, if you want to find out the volume left, then obviously it means you have to do division. You have to take this 9,600, divide by this volume per pail. Now, of course, if you key in calculator, right, it will give you a decimal. So it will give you 6.4 pail. But the thing is, we can't write 6.4 because this answer represents number of pails, right? When you take this water divided by water per pail, you are getting the number of pails. So you can't have 0.4 pails. So what you should instead present, what you do instead is to present it as a remainder. So in front of the point, you put a 6 first, 6 pails, must understand what this 6 represents. And the remainder you got to recalculate out. Do not use the 0.4 anymore. The 0.4 is useless already. Okay, so to calculate the remainder, you can do 6 multiplied by 1,500 because you have 6 sets of 1,500 here. So 6 times 1,500, you should get 9,000. Then you can take 9,600 minus that 9,000. This one just need to press calculator. So you should get a 600 here. And what does this remainder 600 mean? This remainder will be the remaining volume of water left in the tank because 9,600 is cm3 of water. So this 600 naturally also is the cm3. So the remainder units always follow the first answer. First number. First number is cm3, remainder will be cm3. First number is cubes, remainder will be cubes. Something like that. Okay. So this is the leftover. So there you go. You have answered the question. The water left in the tank is actually 600 cubic centimeter. Okay, this is the last question already. So thank you very much. I'll stop here.